Kp greater than Kq. Spring constant of P is greater than spring constant of Q. Okay, first by the same amount, then Y the same force. Then by the same force, the work done by the spring Wp and Wq are related as in case A and case B. See, it is given that Kp, spring constant of the first spring, is greater than spring constant of the second spring. This is given. Now, they are stretched by the same amount, means elongation x is same. Okay, then we can write Wp, this is equal to half Kp into x square. Wq, that is equal to half Kq into x square, because elongation is same in the first case. Then we can write Wp by Wq is equal to Kp by Kq. Now it is given that Kp is greater than Kq, so we can write Wp is greater than Wq in first case. Okay. In the second case, it is said that they are stretched by same force. Now x is not constant, rather force is constant. So when force is constant, you can write work done Wp in the second case as f square by 2 Kp. Okay. When force is constant, then it is written in terms of f square by 2 Kp. Similarly, Wq will become f square by 2 Kq. Okay. Now how it comes? Because you know that work done equal to half kx square. Okay. Then we can write here kx whole square by 2k, and you can immediately write kx equal to f. So it can be written in this format also, f square by 2k. That is also the form of the work done. So if force is constant, then you have to write through this form, that f square by 2 Kp is Wp and Wq equal to f square by 2 Kq. And you can see that Wp by Wq is now coming Kq by Kp, that is they are inversely proportional. Work done is inversely proportional to the spring constant when force is constant, and when elongation is constant, then it is directly proportional. So now we can write that Wp is less than Wq, because Kq is smaller. So Wp will be less than Wq. So when elongation is same, then Wp greater than Wq. When force applied to stretch is same, then Wp less than Wq. So option Option 3 is correct. Option 3. First case P is greater, second case Q is greater. So option 3 is correct. 10 kg moving in x direction with a constant speed of 10 meter per second is subjected to a retarding force of F equal to 0.1 x joule per meter during its travel from x equal to 20 meter to 30 meter. Its final kinetic energy will be. We will use work energy theorem in this case. So work done by the applied force, that is equal to change in kinetic energy. So Kf minus Ki will be equal to work done by the applied force, F dx. Okay, between limits xi to xf. So this is the work done by the applied force. Then we can write here, it is kf minus half into mass of the particle. Mass of the particle is given 10 into velocity of the particle 10 square. So that is initial kinetic energy, that is equal to work done by the retarding force. Retarding force means minus, so we have to put a minus sign. Integral 20 to 30, that constant is 0.1, so it will be minus this one will be kf minus this one will be 500 equal to that one x square by 2, so it is minus 0.1 by 2 into x square. X square means with limit it will be 30 square minus 20 square, so 900 minus 400, that is 500. 500 into 0.1 means 50, 50 by 2, that is 25. So kf equal to 500 minus 25, that is 475 joule. This is the final kinetic energy. So we simply use work energy theorem to solve the problem. Difference of kinetic energy equal to work done by the applied force. Then question number 8. A particle of mass m is driven by a machine that delivers a constant power k watt. If the particle starts from rest, the force on the particle at time t, means you have to find out force as a function of time, where power is constant. Power is constant, that is given k. You have to find out force as a function of time. See, we can write that power P means dw dt. So dw dt is power which is given constant k. Okay. Now d dt of w is equivalent to the kinetic energy, because initial kinetic energy is 0. So you can write this quantity is d dt of half m v square, that is equal to k. Then we can write from this that d of v square equal to 2 by m k dt. Okay, d of v square equal to 2k by m dt. Now I will integrate on both sides. Suppose 0 to t and here 0 to v. So this will simply give you v square minus 0. So v square is coming 2k by m into t. 2k by m into t. Okay. Now from this you can write v equal to root over of 2k by m t to the power half. Now differentiate once again to find acceleration a. This will be root over of 2k by m into half t to the power minus half. So we find already acceleration, multiply both sides by mass, you will get force. So force equal to ma that is root over of 2k by m into m by 2 into t to the power, sorry, this one is minus half. This one is minus half. After differentiating this one, t to the power half, so its derivative will be half t to the power minus half. Okay. So take this term inside the root. It will be 2k by m into m square by 4 t to the power minus half. One m will cancel, this 2 will cancel, so it will be root over of mk by 2 t to the power minus half. This is the value of force. Option 1. So this is not the only method. You can solve this problem in various methods, because if from first line you can also write power equal to F into V. From that you can also eliminate in a different way. But anyhow, force has to be calculated in terms of time. That is given in the that is required in the question. Force as a function of time, because it may be that you can express force as a function of x or as a function of velocity, but from that you cannot find the answer, because in the answer force is given as a function of time. Next one is very easy. Total energy is always conserved. That means initial kinetic energy half m u1 square plus half m u2 square will be equal to half m v1 square plus half m v2 square plus energy produced, E. So correct option is, when that E is taken on the left side, half m1 u1 square plus half m2 u2 square minus E equal to half m1 v1 square plus half m2 v2 square. That is option 3. Because initially total energy is kinetic, final energy is kinetic plus the excited energy due to excitation. So option 3 is correct. Now question number 10. In this paper, whenever there is a ray optics question comes, I will call one of you. Newton, ray optics, corpuscular theory of light, and he said that he is second best just after Newton in ray optics. There are two, this is a rod, it is supported on two parallel knife edges, at this end, at this end. Okay, this rod is supported. Edges A, this is B. Now entire weight of the rod is passing through its center of mass, this one, in this direction. There are two other forces given by the two knife edge, those are normal reactions. This one, suppose NA, there is NB, normal reactions on the rod. Now you have to find the normal reaction given by A. The center of mass of the rod is at a distance x from A. Okay. Entire length of the rod is given D. The center of mass is not at the center, means rod is not uniform. So we will just draw it here. This distance is given x. So this point is center of mass. Since it is not uniform, that's why it is said that center of mass is at a distance x from end A. Okay. Now, since the rod is in equilibrium, we can always write that NA plus NB equal to W for translational equilibrium, but that is not required for our question, for this question. We only require that no rotational motion is produced. That means that rod is in both translational equilibrium and rotational equilibrium. So from the concept of rotational equilibrium, we can only solve this problem very easily. How? What force you have to determine? The normal reaction given by knife edge A. Okay? In terms of the others, in terms of the weight and all this. And this total distance is given D. This total distance of this rod is given D. Now, we want to find the moment of the force, all the forces about this point B. Okay, moment of all the forces about point B I want to find. Then what is the moment of NB about B? 0, because its line of action passes through the same point B. Okay, so this force cannot produce any moment about this point, since I considered the moment calculation about this point B. Okay, then the two other forces are not passing through point B, so they will have a moment, non-zero moment about point B. Now see, NA will try to produce a clockwise moment, because if you fix this portion, then due to NA it will rotate like this, so it will produce a clockwise moment, and due to W it will produce an anti-clockwise moment. So clockwise moment is considered as negative, anti-clockwise moment is considered as positive. So for NA, what is the moment about B? That is force NA into this perpendicular distance. This perpendicular distance is D. So NA into D with a minus sign. Similarly for W, what is the moment? Positive. It is W into distance. See, from this point, center of mass to B, this distance is D minus X. So sum of both the moments should be 0 for rotational equilibrium. Okay, so from that you can calculate that NA equal to W into D minus X by D. That is the answer. Now, anyone, can you tell me, if I do not take B, if I do not take B to be the point about which moment is calculated, if I take center of mass itself, and about center of mass we try to calculate the moment, or about A we will calculate the moment, then can we find NA? How? If I calculate the moment about point A or about center of mass, then how can we find NA? See, then you have to use the translational equilibrium's equation again, because then you have two equations, because for calculation of NA in terms of W, NB has to be eliminated. Okay, but if you calculate the moment about center of mass, then the rotational equilibrium equation will contain NA and NB both. Okay, then from the translational equilibrium equation, that is NA plus NB equal to W, you have to eliminate NB and find this relation. Or if you calculate through this, point, then NA's torque will be 0, so NA term is absent, so you have NB. Then in the translational equilibrium you have to substitute the value of NB to find the value of NA. So it is better to calculate the moment with respect to B. Then NB is automatically eliminated, because through that point, since the line of action of NB passes, so its torque about B will be 0. No further mathematical eliminations is required. From the rotational equilibrium calculation, NB is already eliminated. So that's why you can solve the problem easily. So this one can be written as force, centripetal force. So this will be equal to 4 pi square m by k r square. Now according to Newton's law, this force can be written as G into capital M into small m by r square. This will be 4 pi square m by k r square. Now see, r square cancels, m cancels, so you will get a relation gmk will be equal to 4 pi square. Gm into this k equal to 4 pi square. That is the relation between Kepler's constant and Newton's universal constant of gravitation. See, initially their centers are at a distance of 12 r. When they are in contact, when they come in contact with each other, then what is the distance between their centers? 3 r. That means how much distance they will move? 9 r, because 12 r minus 3 r. Initially their center to center distance 12 r. When they come to contact with each other, means surfaces are in contact, then distance between their center will be 3 r, because one has a radius 2 r, other has a radius r. Means each of them are moving through a distance of 9 r. Now since they are moving with due to mutual gravitational attraction, means we can consider that external force is absent on the system, so center of mass will remain same. Center of mass will remain same in absence of any external force. So we can write the first body m, it moves a distance x, then second body 5m moves a distance 9r minus x, because m1 x1 equal to m2 x2, since center of mass remain same. Because we know that x center of mass will be equal to m1 x1 plus m2 x2 by m1 plus x2, when x1 and x2 all are given in the form of a vector. Then xcm equal to 0, means m1 x1 vector plus m2 x2 vector equal to 0. But when you take that vector sign away, write the scalar equation, then it will be m1 x1 minus m2 x2 equal to 0. So m1 x1 equal to m2 x2. We use that. Because first mass is moving in this way, second mass is moving in this way, so this is x1 and x2. Total distance given 9r. So this one is considered as x, this one is considered as 9r minus x. Okay. Then calculate what is the value of x. It is coming 7.5 r. X equal to 7.5 r. Then on observing light from 3 different stars P, Q, R, it was found that intensity of the violet color is maximum in spectrum of P, intensity of the green color is maximum in spectrum of R, and intensity of red color is maximum in spectrum of Q. See, we know that lambda m proportional to 1 by T. from Wien's displacement law. Okay. Now, highest temperature means least lambda. Highest temperature means least lambda. So, which color among them has least lambda? Violet. So, highest temperature is for violet, that is Tp. Next highest temperature, longer wavelength, least wavelength is green. So, it is Tr. Then Tq. Wavelength for violet is minimum, then wavelength of red is maximum, and wavelength of green comes between these two, and as the wavelength is shorter, temperature is higher from Wien's displacement law. Okay. Next, the approximate depth of the ocean is given, compressibility of water is given. Compressibility factor means inverse of the bulk modulus, and the intensity of water is 10 to the power 3 kg per density of water, or 10 to the power 3 kg per meter cube. Compressibility factor given. What fractional compression, that you have to find out. See, bulk modulus B, that will be equal to P by dV by V. I just neglect the minus sign, so we have to calculate only the magnitude. So, bulk modulus B equal to P by dV by V. Then we can write bulk modulus equal to inverse of the compressibility factor. So, that is 1 by K, that is equal to P by dV by V, means dV by V equal to K times P, and P we know H rho G. Put and calculate. K is given, compressibility factor, density of water given, depth given, and take G and calculate. Pressure can be calculated by that formula, H rho G. Bulk modulus P by dV by V, we have to calculate the fractional compression of water. Fractional compression means dV by V we have to calculate. So, dV by V will be K into P, where K is the compressibility factor and P is H rho G. Okay, so it is option 3. Then question number 17, no need to calculate anything, because just the two ends of a metallic rod maintains at temperature 100 degrees Celsius and 110 degrees Celsius, the rate of heat flow in the rod is found to be 4 joule per second. If the ends are maintained at temperature 200 degrees Celsius, the rate of heat flow. From the radiating, you can also write that dq dt equal to Ka by x into delta T. Okay, rate of heat flow, that is equal to Ka by x. K is conductivity, A is area, x is the length, equal to delta x. Now see, all this K, A and x are same, means dq dt is directly proportional to delta T. dq dt is directly proportional to delta T. So previously what is the difference of temperature? 10. Now the difference of temperature is also 10. So the rate of heat flow will remain same. So answer is 4 joule per second. If x is changed or area is changed, then there is a change. But since both x and a both are same, so Ka by x is constant. So we can write that dq dt is directly proportional to delta T. So delta T in both the cases are same. So dq dt in both the cases are also same. Then next one, Bernoulli's theorem. Apply and solve. So if you are considering the inner portion of the roof and the outer portion of the roof, then we can say that from the ground they are almost at the same height. Inner portion and outer portion, 2 points, they are almost at the same height. So potential energy will be same, and from Bernoulli's equation, from two sides potential energy term will be cancelled. Then we can consider the outside the roof pressure is P1 plus kinetic energy half rho V1 square, kinetic energy per unit volume, and potential energy I will write, but it will cancel, mgh. Then it will be inside the room. Inside the room it is P atmospheric pressure. Said velocity inside the room, static air means velocity 0, so kinetic energy is 0, and this is also mgh. So mgh, these two term cancels. Now we can write that half rho V1 square equal to PA minus P1. You know that static air's pressure is more and moving air's pressure is low. So this is the difference of the pressure, and difference of the pressure will be creating the force. So that will be equal to half rho V1 square equal to F by A. And what is the direction of that force? From the high pressure to low pressure. High pressure is inside, PA. Low pressure is outside, P1. So the force is directed through this. High pressure to low pressure. So now we can calculate F equal to half rho V1 square A. Just multiply and find out. Whenever you will find the examples of the Bernoulli's theorem, that during a cyclone we are asked to open the windows. Why? Because if there is a tin roof of the room and if you close all the windows, then what happens? Inside pressure is more, outside pressure is less. So that tin roof will experience a force from inside to outside, and as a result, whenever during the cyclone roof is damaged, the tin roof is flying away, not falling inside. That is from a Bernoulli's theorem explanation. So it will be 2.4 into 10 to the power 5 Newton, and it should be upward, not downward. Same is another example is there. If a through train is passing through the platform, then passengers are requested to stay away. Why? Because if you are very close to that train, then air in front of you and between the train is moving all due to inertia with a very high velocity with the train, and as a result this side air will produce less pressure, and the air just behind your body is almost static, so it will produce huge pressure, so you will be pushed towards the train. So in which direction you will feel the force? From high pressure to low pressure. Question number 19. Figure below shows two parts that are given, two paths that may be taken by a gas to go from state A to state C. In the process AB, 400 joule of heat is added to the system, and in process BC, 100 joule of heat is added to the system. The heat absorbed by the system in the process AC will be. See, first I consider change in internal energy if the process is this one, A, B, C, A. Then tell me, what is the change in internal energy? 0. But that process is not given. I consider this one, because if it is A to B, then B to C, then again C to A, then it will be a cyclic process, and in cyclic process a change in internal energy will be 0. Okay. Then we can write du equal to dq minus dw. So we can write dq AB CA means dq cyclic will be equal to dw cyclic. Okay, because dq equal to du plus dw. In a cyclic process du is 0, so dq and dw in a cyclic process are equal. So cyclic process is ABCA. Now this ABCA can be written as QAB whose value is given, that is 400 joule, plus QBC, that is also given 100 joule, plus QCA, but we don't require QCA, we require QAC. So I will write that minus QAC. Okay. So actually the cyclic process, the work done should be QAB plus QBC plus QCA. But I require heat energy given for A to C. So QCA can be written as minus of QAC. And that will be equal to work done in the cyclic process, that is area under the curve. So area of the triangle, calculate area of that curve. So this one is 400 plus 100, that is 500 minus QAC, that is equal to area of the curve, that is half into base is BC. BC is 4 minus 2, that is 2 into 10 to the power minus 3 into height. Height is 6 minus 2, that is 4 into 10 to the power 4 Pascal. Calculate. So this one will cancel. So 10 to the power minus 3, 10 to the power minus 4 means 10, 10 into 4, 40. So QAC equal to 460 joule. So dQABCA should be equal to QAB plus QBC plus QCA, but I changed QCA to minus of QAC because I require QAC. Okay. The next one is from thermodynamics, same. A Carnot engine having efficiency eta equal to 1 by 10. Eta equal to 1 by 1 plus beta. So eta is given 1 by 10. So that will be 1 by 1 plus beta. Beta is the coefficient of performance. Then from this we can write 1 plus beta equal to 10 or beta equal to 9. Now Q2 by W, that is equal to beta. W is given 10. So Q2 equal to 9 into 10, that is 90 joule. Relation between efficiency and coefficient of performance, that is eta equal to 1 by 1 plus beta. So from that eta is given 1 by 10, from that we calculate beta, that is 9, coefficient of performance. Then Q2 by W is the coefficient of performance, equate W is given, find Q2. This is the amount of energy absorbed by the reservoir at low temperature. The fundamental frequency of a closed organ pipe of length 20 centimeter is fundamental frequency of a closed organ pipe, that is V by 4 LC closed organ pipe. I consider length of the closed organ pipe is LC. Then fundamental frequency is V by 4 LC, V by 4L is equal to the second overtone of an open organ pipe. Second overtone in open organ pipe means third harmonic. That means 3V by 2L open. Okay, 3V by 2L open. Third harmonic is the second overtone here. So it is given that closed organ pipe length is given 20 centimeter. This V cancels, this 2 cancels. So you have to find LO equal to 6LC. It is given 20, so 20 into 6, that is 120 centimeter. Okay. Next one is also very easy. Parallel plate capacitor and then cell of EMF charge and then disconnected. Disconnected means charge remain constant. Whatever dielectric slab you will insert or not, charge will remain constant. So the last option is only wrong. The charge on the capacitor is not conserved. So that is only wrong option. So option 4. The next one, the electric field in a region is acting radially outward. In a region, in a certain region is acting radially outward and is given by E equal to AR. A charge contained in a sphere of radius A entered at that the origin of the field will be given by. Okay, see, electric field is given A into R. Okay, then at a distance R, what is the value of the field? At a distance small a, means where R equal to small a, that means A into small a. And then from Gauss's law we know that E into area, so we know that Q enclosed by epsilon naught equal to E into area according to Gauss's law. So it will be Q enclosed equal to 4 pi, this epsilon naught is divided by epsilon naught. E is A into small a and area is 4 pi radius a, so it is 4 pi a square. So just multiply and write Q enclosed equal to 4 pi epsilon naught capital A cube. This is coming from, this line is I have written from Gauss's law. Since E is radially outward and surface is a sphere, so area vector is also radially outward, so no need to integrate, just you can multiply E into area of the sphere, as area of the sphere is 4 pi small a square here. So option 3 is correct. Then potentiometer, not in the syllabus. Then come to 29. See, ABC are 3 voltmeters, resistance given R 1.5 R 3 R. Okay. First calculate the equivalent resistance of B and C. Calculate and tell me the equivalent resistance of B and C only. B B has a resistance 1.5 R and C has a resistance 3 R. Then what is the equivalent resistance of B and C? They are in parallel. So it will be 1.5 into 3 by 1.5 plus 3. That is 4.5 by 4.5, that is R. So equivalent resistance of B and C is R. Now check. A is also has a resistance R. So the potential between X and Y is V, that is divided equally. So A has a potential of V by 2. Combination of BC has a potential of V by 2. But B and C are in parallel. So each B and C has a potential difference of V by 2. So all have the same potential. A and equivalent of BC have the same resistance. So if they are maintained between potential V, then potential is divided equally because current is same. So potential divides equally. So A has a potential of V by 2, BC's combination has a potential of V by 2. But since B and C are in parallel, each have the potential V by 2. So all have the same potential. So first option is correct. Then across a metallic conductor of non-uniform cross section, a constant potential difference is applied. The quantity which remain constant along the conductor: current density, current, drift velocity, electric field. Which one? See, non-uniform conductor can be drawn like this. Okay. They are maintained between certain potential difference. Now we can see that this non-uniform conductor, so I will break it into different section. So we can consider each section is of different resistance. So let us consider this conductor like this. Like this. So suppose R1, R2, R3, R4 and so on. So we can consider different fragments of this entire conductor are in series combination, and in its series combination which one is constant? Current. So current is the constant. Non-uniform cross-sectional area. Cross-sectional area non-uniform means resistance will change. Resistance changes, but we can consider all such sections are different resistance connected in series, and in series combination current remain constant.